Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video, I will show you the full assembly of my Solidworks Make Frother project. In my previous video, I have already shown you how I have done part modeling, start from the bottom casing, top casing, and all the other parts. Alright, since I have completed all the parts modeling for my Make Frother, so now in this video, I would like to show you how I will do full assembly in Solidworks. Okay, to do this full assembly in Solidworks, I will click at New. So I will go assembly, then I click OK. Okay, automatically Solidworks will ask for the component in folder that I can insert into this assembly. So here is already asked in under new folder 2. Okay, in my new folder 2, I have all the parts modeling that I've done, including the standard component like battery connector, DC motor, and tactile switch. Alright, so before I select component to be inserted in this assembly file, okay, the first thing that is very important because you need to think which component will be your base component. Okay, for the case of Make Frother, the base component should be the bottom casing, because the bottom casing is the base, because when we do assemble, we will start from the bottom casing, then we will assemble, we will mount all the other components like motor, like battery connector, the rod, and so on top of that bottom casing. It means like bottom casing is like your platform. So I will go first the bottom casing. So since the bottom casing is a base component, then I click open. Okay, for the base component, the first component you want to insert here, so I will not click on the screen, I just simply bring it to OK button. So it means that this bottom casing is my first component and it is a base component, it is placed at the origin point. Alright, if you look in your property managers here, the bottom casing we have bracket F. F means it is in fixed mode. Fixed mode means I cannot move it. Okay, by the way, I can make this fixed mode float. If you look on the menu float, if I make it float, it means that I can move the bottom casing. Okay, let me remain this bottom casing in fixed mode because it is a base component. Okay, now I will go, if I click at insert component, then I will select everything here. If I select everything except the bottom casing, then I click open. Hold on. Okay, the first I put the battery is somewhere around here. Then this is a metal connector, I put it at this location. This is at the back metal connector, I put somewhere around there. This is another back metal connector. The motor, I put it in front here. Now I have the coupler, I put it somewhere around here. And this is opening lid, I put it at the back. And now this is the plastic cap, I put it here. This is the push button mounted on the opening lid, I put it at the back. And this is my steering rod, I put it in front. And this is the tactile switch, I put it at the back. And this one is the bracket to hold the tactile switch, I put it at the back here. And this is my top casing, I put somewhere at the top here. Alright, I have already inserted all the components. Okay, my next move, since I have put all the components here, so then I will do the assembly. Okay, since I have put the first component, which is the bottom casing, so this bottom casing will be my base component. Okay, when you do assembly, so this is very important. Okay, since the bottom casing is my base component, so it will be kind of like a platform. So when you do assembly, you have to assemble your components in order. Okay, if the bottom casing is your base, the next thing to do, what you will mount on top of this bottom casing will be DC motor. So it's kind of like in order. You cannot simply randomly do mate setting and randomly picking component for the assembly. A good practice is that you need to put the way the assemble of your component in order. Okay, since the bottom casing is the base, so the next component should be mounted on top of this bottom casing, should be the DC motor. So I will go for the C motor for my first mate setting. So I go for mate, then I will click at this. Since the motor we have the shaft, I click at that cylindrical shaft, then it concentrate with this cylindrical surface. Then I click OK first. You must click OK to make sure that SolidWorks already read your first setting. I can simply drag like this, my motor, but it have the concentric relation. And I will select this surface and this surface, and it goes parallel. Then I can drag my motor like this. Then I need to put this face and this face. Then it go for coincidence. So now my DC motor is in position. Alright, so DC motor is in the right position. Okay, my next one to be put in my bed setting is this. I have done this part modeling of this plastic coupler. Okay, I need to put the coupler in exact position. Alright, so let me drag first. Okay, now I go for the second bed setting. The coupler, I have the cylindrical surface and it mesh this shaft. Okay, then let me drag first the coupler like this. Alright, my next main setting, sometimes it's hard to select the inner surface there. So you can do section view. If I go for this section view, I click OK. Okay, this is my plastic coupler. Let me drag it like this. Okay, my next make setting is that the inner surface of this coupler must touch the surface of the shaft of the motor. So now the coupler is in position. Alright, if I click OK like this, and if I hold on, if I on off the session view, actually the plastic coupler is this orientation. Okay, now let me off. Okay, let me go for the next mate setting, which is the steering rod here. So I go for this mate setting for the steering rod. So this cylindrical surface and this cylindrical surface, it goes to concentric. Let me drag like this, and this surface must touch the surface, right? Okay, by the way, just to mention to you, this is a simple plastic coupler. The way they join the shaft of the motor and also the shaft of the steering rod inside this coupler by kind like they will use glue, right? Kind of fixed connected. Right. Okay, let me click OK first. And let me off my section view. So now my steering rod is in position. Okay, another thing about the steering rod here, if you look the orientation, if I go for the standard view, okay, this steering rod I can still kind like, if I select this arm, hold on, this arm can still be rotated like this, but I don't want this orientation like this. I want this arm, the orientation of this arm is goes for horizontal. Okay, in order for me to do that, since I create this arm by 3D sketch here, I will open this opening rod here. I open the part modeling file of this steering rod. Okay, since I made this, I have a sketch here. Okay, this sketch is, if you look here under the surface sweep, under the sweep, the 3D sketch, I must on. Okay, by default it's off. I on it, so the sketch is there. So I need to make a plane that really coincide with this line. So that plane will be used for my mate setting in assembly. Okay, let me show you. So here under reference geometry, I will click plane. Okay, my first reference is this line. Okay, second reference, I should go for the front plane. So I have this plane. If you look here, I have a plane. Hold on, I have a plane number 4. Okay, let me save first this steering rod file. Okay, if I go back to the assembly file, okay, hold on. Okay, this assembly file, okay, here, if you look I will do another match setting. Okay, if I go for match setting, okay, under the listing here, my first match setting, I want my, okay, I will go for this list. I will go for the steering rod. Hold on, the steering rod. So here the steering rod, I will open it. The last one is that plane 4. Okay, it's already highlighted the plane 4 with this surface. Then automatically it goes for parallel. Then I click OK. Okay, like I click OK. Then if you look, the steering rod is parallel with that this surface. Okay, it kind of like go for horizontal, right? Okay, the next one will be this plastic cap here. Okay, this plastic cap. So I'll go another mid setting. So I have a cylindrical surface. This one with this one. Then it goes like that. And this surface will touch this surface. Then I click OK. Now my plastic cap is in position. Alright. Okay, just to mention to you, in my previous video, I've shown you how I have done this plastic cap. If you look on the section view, just to show that this plastic cap really blends inside the internal of this casing. Okay, there is no interference. If I go for uh, another section view here, this section view, okay, kind of like if I, okay, if I on, I have not put my top casing into position. Actually, the plastic cap is kind of like nicely blend inside this bottom casing and top casing. Okay. Okay, my next move is that since I have put the rod, the plastic cap, and coupler, and also the motor in position, the next one will be this metal plate. Alright, this metal plate, I will do my next mate setting. Alright, this metal plate, I can go for, okay, for this metal plate, alright, I can, this one, this cylindrical surface, and this cylindrical surface, hold on, this cylindrical surface, and it go for concentric, but I want it to turn to the other direction. Here under mate alignment, I go for, by default is left. I click at the right one, go for entail line, so it pointing to that direction. I must click OK first, so it will read the setting. I can still drag it, but it have concentric relation with this one. Alright. Okay, another thing is about, okay, this cylindrical surface and this cylindrical surface, and it goes for concentric, and I can still drag these metal connectors, and the third setting will be this face will touch this inner face. And now my metal connectors, battery connectors is in position, okay, at the right position, right? Okay, let me save my assembly file first. So I will go for this new folder 2, I will go for assembly 1. Alright, since I put the motor, the metal connectors, and the steering rod, and the coupler, and the cap in position, okay, next will be the battery. Okay, then I will mount the battery in position. Okay, now I will go for main. So I will select this battery. Then I will go for this cylindrical surface. Okay, it turns to the other direction. If you look, this metal connector, we have the protruding things here. So I think the battery is wrong orientation. So I go for the anti line. So it will go to the other direction. Then I must click OK first. Then we have our first setting. And this battery, I can still slide it. Okay. Now about the position here, the face must go here, right? So now my AAA batteries, the first one is in position. Let me click OK first. Alright, since I have the first battery here, I can clone it by hold on my control and select it. And I've cloned the second to make the second battery. Okay, for the second battery, I will do the mid. Okay, this cylindrical surface and this cylindrical surface, it goes like that. But I need to turn it to the other direction, so I will go under mid alignment, I go for enter line. Then I must click OK first. Okay, I can drag it like this, and this space and this space will be coincident, right? So my, hold on. Okay, then my second battery is in position. Okay. Okay, let me save my file again. All right. Okay, the next thing to do is that, okay, I will do here, I have the opening lid at the back here, right? Okay, first I will do the sub-assembly first of the opening lid because all the other components around the opening lid here will be mounted onto this opening lid. I will do this sub-assembly first, then after I've done this sub-assembly, then only I will assemble to this main casing. Alright, okay, to do that, when I do sub-assembly this opening lid, I must make sure this opening lid will not because it's still in float, can be moved. So I will select right click at the opening lid, I make it fixed. So it means that opening lid cannot be moved. Okay, okay, now I will do the mate setting for this opening lid. Okay, the first thing for the opening lid should be this push button. So I will go for mate. Okay, the push button, I will select the cylindrical surface and in mesh this cylindrical surface. Then I click OK. Then I can simply drag it like this. And this face must touch this face. And now my push button is in position. Alright. Okay, the next one will be, since I put the push button in position, the next one will be this bracket that hold the tactile switch, right? So for this bracket, what I will do, okay, I can go for, okay, this bracket, I can go for this face. It's in line with this face. Okay, I click OK first. Okay, if you look here, the bracket is in line in terms of level on the top plane. Okay, but still I need to put the metal plate in the right position. All right, the next setting for this bracket here, this face must be in level with this face. Okay, now the bracket is in the second position, second setting. And another thing is about, okay, I can go for this surface of this bracket will touch this surface. So now the bracket here, let me click OK first. So this bracket is in fixed position, all right? Actually, we have a pin there, okay? All right, okay, the next one will be this tactile switch. Okay, this tactile switch, if I go for mat setting again, the tactile switch, so I will go for this cylindrical, hold on, this cylindrical surface of the tactile switch will mesh with this cylindrical surface, but it turns, the orientation of this tactile switch, it turns to this direction, so I will go for here, anti-align, so then I click OK first. All right, since this data switch kind of like, I can track it, I bring it like this, right? Okay, so already have the concentric relation with that push button. Okay, let me just simply turn this data switch. I want this orientation. Okay, another thing is about this face and this face must be in parallel. Then it goes for parallel. Then I can still drag this data switch. And the third setting is that this face must touch that push button bottom surface. Right, then I click OK. Now my tactile switch is in position, right? Okay, my next move is that about these two battery connectors at the back here. I have two of them, so these battery connectors should be on the right side since we have this flat head of these battery connectors would be in line with the battery on the right. We have a flat head, right? But I don't want to do the main alignment of this battery connectors with the battery. I will do the main alignment to put into the slot of this opening lid. Alright, to do that, okay, here I have this face of this battery connectors. So I will do mate. So I will put this face, will mesh with this face. So Solidworks put it into coincide. I must click OK first to set the first setting. So it means these battery connectors are in that position. Right, and my next setting would be is that I want this face. must be coincide with the bottom face here. Okay, SolidWorks put into coincident, then I click OK. So it's turning to that direction. So my third setting is that I want the position of this surface of this arm of this battery connectors must be in line with this face. Okay, so now the battery connectors on the right is in position, in fixed position. Okay, about this battery connectors, let me put it to the side. All right, similar approach. This face must in line with this face. I click OK to check for the first setting. Let me drag a little bit here. And about this arm, it must mesh. It's kind of like I need to put to this space. Then it will go to coincide. So this arm is there. Okay, I can simply drag it like this. Okay, now this face must touch this face. Click OK. Okay, now I have the third setting for these battery connectors. I click OK. Okay, now these two battery connectors are in fixed position. Okay, my next move is that, okay, since all the components of this opener lid are in position, it means that I've done this sub-assembly of this opener lid. Alright, okay, at the beginning, I have set this opener lid in fixed mode. If you look the list here, we have this opener lid is in bracket F, so it's in fixed mode. So it means I cannot move this opener lid. So what I need to do, I have to right click at this opener lid and make it float. Right, so it means that if I move this opener lid, all the components will follow because I have already done the sub-assembly of this opener lid. Alright, okay, my next move is that, okay, I need to put this opening lid in the exact position. Alright, okay, to do that here, under the mate here, alright, since I have these batteries connectors, I have a cylindrical surface. So I will go the cylindrical surface of this battery connectors must match with this cylindrical surface of this battery. Then I click OK, I have the first setting. So it shares the same center point. But on the right, if I can still swing this opening lid, but on the left it have the concentric relation. So I need to set another concentric relation for the cylindrical surface. Okay, I select this cylindrical surface and this battery, then automatically SolidWorks put into concentric location. Okay, if you look here, now my opening lid is in a line, okay, with those two batteries. Okay, my next setting for this opening lid is that, okay, this surface of this opening lid must touch this surface of the bottom casing. Then I click OK. So this will be my third setting. If you look here now, my opening lid is in exact location, right? Everything is good. Okay, now I click OK first. Alright, my last mate setting will be this top casing here. So I go for mate. I select this surface will mesh with this surface. So I click OK, and SolidWorks put the surface and the surface of this bottom casing into coincident. It means that it is in line. Okay, my second setting will be this face must mesh with this face. Right, my third setting is that I have a circular edge of this top casing must mesh with this circular edge of this cap. Okay, I have the option either to use tangent or coincide, but I go for concentric. So Solidworks will put that top casing have the same center point with this outline of this cap. Alright, now my top casing is in the right position. Let me click OK first. Okay, let me go for standard view. Okay, let me go for section view to look for final check. Okay, everything is good. All the components are in the exact location. Let me go for this section view. Okay, good. Everything is in. All the components are in the exact location. Right, Alhamdulillah, I have completed my full assembly of my milk frother. Okay, inshallah, in the next video, I will show you how I will do exploded view of this milk frother. Okay, thanks for watching this video, but before that, please do not forget to click subscribe and like my channel. Assalamualaikum warahmatullahi wabarakatuh.